Hi, we are Contromax. We develop electromechanical actuators, servos, for aircraft, meaning it's not just an actuator that you can easily see around, but this is a safety and flight critical component for your flying applications.
We are located in South Korea. The company was founded in 2014 with a strong motivation that let's provide more reliable and transparent servos. That's why we released this video.
These days, there are many flying mobility applications under development in the world, like vertical takeoff and landing, personal air vehicle, or air taxi and unmanned aircraft system. These applications are our primary interest because they all need a type of servo, like controlling wing surface, swash plate, steering, brake, and a certain structure position. They are where our Contromax series can help. Currently, we have several models, from low torque to high torque model like Contromax 20, 25, 50, 100, 150, 300, and 500 for 500 kg force centimeter. Also, Contromax 50 with duplex motors if a lower failure rate is required. In addition, we can provide a service developing a customized gearbox if it can save your time and effort. A few more servos designed to improve safety according to the aviation practice will be released in near future soon, like having dual motors, dual controller with dissimilar electronic hardware and software with different development tools and engineers, separated and segregated connectors and minimized single point of failure.
If we wanted to become just an ordinary servo company, like many in the world, we wouldn't have started this business. Daniel, the company's CEO with more than 24-year experience in aircraft actuator development, and other motion control experts in the company. We have not only actuator control background, but also aviation background too.
So, we understand the challenges you might have faced, but very likely, such as limited servo availability in the market for your specific needs, shape and weight constraints to your vehicle installation, or customized electronic interface. Why would we just sit and watch such challenges happening again and again every time when your aircraft program is established? We wanted to help. How? Let's have a look. Number 1. Lead time. Have you ever experienced to find a servo in time while your program is always behind the schedule because of servos? Or because of the fact that all aircraft are different, meaning ideally all aircraft need a specific type of servo optimized for their vehicles, which takes time and makes the servo delivery a bottleneck. Long lead time is generally caused by motor and gear train. About the motor, we've been working with very stable European motor supply partners since the start of this business, so we can pick and choose one if you need a new servo. The range is wide enough to accommodate a new servo requirement. Plus, we understand how to control those motors for your application, which requires low current consumption, high torque without generating too much electromagnetic noise, acoustic noise, and aiming to increase the lifetime of the servos. About gear train, we have our own hobbing machine to manufacture gear train. Gear train is a collection of mechanical parts under high amount of friction, pressure, stress, and eventually fatigue, which may break the parts. Not many servo companies have such expensive and high precision machine, which requires outstanding skills and experience beyond just machine operation, but we do, and gear inspection facilities too.
Number 2. Analysis and test. We don't just manufacture, we think first based on the aviation best practices like FMEA and FTA to find single point of failure and any common mode error or failure. And also verification with environmental test with our own climate test chamber and by using external test facilities for electromagnetic compliance. Besides, we make custom test benches and in-house test software very quickly. It's not that difficult because that's what we do.
Number 3. Cross-check. We understand how dangerous it can be if you think alone, make alone, and test something alone. That's strongly against the aviation culture, which is built on the fact that we all make a mistake.
Therefore, we talk together, share what we learned from no matter if it was failure or success.
For instance, we are using different microcontrollers, MCU A and B if it's for safety-critical applications, to minimize errors, meaning there are different engineers in the company doing different design, different implementation by making different test cases. In addition, we are still learning. There is one story which might have sounded very critical for you. It's about servo jitter, or somebody may call it self-oscillation. When the servo is connected to aircraft structure like a control surface or vane, depending on their dynamics, it vibrates itself. Looks severe, isn't it?
So we have developed a few solutions together. 1. Anti-jitter logic. Jitter is normally induced by high gear ratio while you're using digital sensor to control a motor. We use analog sensor instead of digital sensor, meaning the motor control is precise enough to prevent jitter even when the final up-shaft position is deviated by extremely small degree.
Another solution is the servo detects the jitter as quickly as possible and stops it. It may reduce some control accuracy and delay the response time, but it will keep the servo intact, meaning it will increase your aircraft survivability before the servo goes to the state of total loss.
So basically we collect ideas to find out better solution out of the box by inviting all different perspectives, such that we understand this is not optional but essential to be aligned with aviation culture to secure the safety. We are taking care of your loved ones to return to your home from the sky.
To quantify the safety and reliability, we are following FAA and EASA's best practices and guidance because we understand aircraft manufacturers' concern. Again, we want to help your business.
Let's recap quickly. You need a servo for torque width, a travel range, angular speed, and a certain level of lifetime. We understand they are crucial for your application, but we think they are just bare minimum.
We know you need something beyond like electronic hardware and software assurance, simply compliance against the RTCA D0178 and 254. You will want to identify what kind of failure modes the servos may have and what detrimental effects they may make to your application, so-called aircraft failure conditions. These are explained in SAE ARP 4761 and 4754.
You will need much more information to make the servo white box, not just accept it as black box. We can share common mode error failure, failure propagation mechanism, failure rate calculation by using a dedicated standard like MIL Handbook 217. There are much more ideas and internal projects ongoing. Or these may not be perfect solutions and may not end up being always successful, but the message we'd like to deliver to the world is that we study, learn, and keep trying to improve our products. Why and how? We love servers like you love your application.
Are you interested? Let's talk. Contromax.